All right, guys, we're going to begin our dive into chapter 10, starting at 10, verse 1, area of rectangles, squares, and parallelograms. So, we're going to be talking about different types of polygons, more specifically quadrilaterals, quite a bit, just like we focused on in chapter 6. And again, here we're going to be talking about area. So, our first mission here is I can determine the area of rectangles, squares, and parallelograms. So one of the first things we need to think about, and just in a general context, is the concept of area. So when we're talking about area, we're talking about two dimensions. Okay, so if you think about the floor, it has a length and a width. If you think about the wall, it has a length and a width, as well as the ceiling would have a length and a width as well. So most of the times when we've been talking about area in a grade school context, we have been looking at this as area equals length times width. I want to change your mentality just a little bit, and we're actually going to use some different definitions for this. Very similar, but you're going to understand why that we're going to use that as we move along, because we're actually going to build on this new definition of area as we move through these different parallelograms, and it's going to help you to remember them as well. One of the things I figured out is that a lot of times we just don't remember formulas very well, and it's because they're either not familiar to us or there's no way really for us to remember them. There's nothing to kind of trigger us to remember. So that's the reason I want to kind of change to different definition. And this is the definition they use in high school context anyway. So I want you to think about the fact that area really is base times height. Okay, area is base times height. And so let's just fire it in, looking at an example here, and then we'll kind of talk about some different things about this. So let's imagine that I have a rectangle here, and let's say it's 4 centimeters by 3 centimeters. Okay, and you remember with a rectangle, specifically these sides would be the same, these other sides would be the same, and you would also have at least one 90-degree angle, right? And as long as you have these conditions with these sides and it's one 90-degree angle, we understand that there's really a 90-degree angle everywhere here, okay? So a couple of things we need to talk about here as we kind of move through this. Area equals base times height. This height here is the perpendicular. I probably spelled that wrong, but it's okay. Perpendicular height, okay? So you need to recognize and understand that that always has to be the perpendicular height. And that is the case here again, because I have 90-degree angles in these corners. I would understand that this 3 centimeters is in fact a perpendicular height. And it doesn't mean very much right now, but it will when we get into some other things here again as we kind of move along. But again, if I'm thinking about the area of this rectangle right here, I'm thinking about how much two-dimensional space does it take up. And so think about this one that we've got right here. We've said that area equals base times height. Okay, so again, what I would do is I'm going to take my base. This would be my base here, 4 centimeters, and I'm going to multiply that times 3 centimeters. Now I want you to think about what really happens here. So the numbers themselves, right? The numbers themselves, 4 times 3 just gives us 12. Okay, but what happens here? I've got centimeters times centimeters. So what really happens when I take a number times itself? In other words, if I take 2 times 2, I'm going to get 4, right? And if I take 3 times 3, I'm also going to get 9. So when I take a number times itself, it's just like squaring that number, right? So 3 squared is the same thing as 3 times 3, and 3 squared actually equals 9 as well. So I want you to understand, when you take something and you multiply it times itself, it's really just squaring that. So when we're talking about area, we should always have our answers in squared terms. So in other words, 4 centimeters times 3 centimeters is 12 centimeters squared, or 12 square centimeters, all right? And you may be thinking, well, that don't make any sense. Why would we express area in terms of something squared? Well, I want you to consider something over here with this rectangle that we just made, okay? Think about, what if, now this is 3 centimeters from top to bottom, right? What if, for example, split this into 3 equal parts, okay? And again, what if, for example, I split this into 4 equal rows. Now, I know those are not very equal, but just use your imagination for just a second and think about the fact then that this would be then a 1 by 1 square. And this would be a 1 by 1 square. And all of these, in fact, would be 1 by 1 squares. Well, think about how many 1 by 1 squares, remember squares, that I really have. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just so happens I have 12 square centimeters, okay? So you kind of get the idea of why we use that notation for these particular instances. So let's work through a few problems here real quick, and I'll kind of give you an idea of what you're going to be seeing on your practice as well. So again, if I have another rectangle, maybe that I've got 6 feet, and here I have 2 feet. Sorry, I made the same congruency mark. So again, we know that is a rectangle just based on that information right there. So very simply, I just take my base times my height. So my base would be 6. My height would be 2. So that equals 12. But remember, I got to think about my units. So it would be 12 feet squared, or 12 square feet is another way that we would say that, okay? The other thing you're going to have to do is you're going to have to kind of work backwards, which means you're going to be given the area, and you're going to be asked to either find a base or a height. So let me give you an example of that as well. So again, we make our rectangle, and here we're going to have this be the question mark. We don't really know what that is. But then they're telling you that the area equals 56 centimeters squared, okay? So again, think about, how do I get area? And this is why writing the formulas really helps you to understand and get this from a repetition standpoint. So area equals base times height. Now let's fill in what we know. Well, we know the area is 56. So I'm going to go ahead and put that right there. The base is what we do not know, so I'll just leave it as B, okay? This is B. And then it is times 7, right? Because I know that this would be, in fact, be my height. So now I'm really looking for B. Well, how do I undo B times 7? I've got to do the opposite, or the inverse, which is to divide by 7. So really all I'm doing is taking this area that they're giving me, and I'm dividing out whatever one side I have. And you'll notice what that gives me is 8 centimeters. So that means this has to be 8 centimeters. So again, that's kind of an example of what you're going to be doing. You're going to have both types of these problems as you move through your practice. So now let's talk about a square for just a second, because a square has very similar characteristics with it, in that there is 90-degree angles right in every single corner. We learned that in the last chapter. We also learned that it has 4 congruent sides. So now when I'm thinking about this, if this is, for example, 2 centimeters, then I know then that this also has to be 2 centimeters as well. They don't even have to tell me that. I can look at the congruency marks, and I can tell that that would be the case. So this is going to be 2 centimeters as well. And again, my formula is area equals base times height. So think about what really happens here. I've really got 2 centimeters times 2 centimeters. Well, what ends up happening here is I have 2 times 2, which is 4, and I'm going to have centimeters squared. I want you to think about the fact that in a square, my base and my height are exactly the same. So really all that I would have to do is just say area equals base squared. Okay, that would be the same exact thing as this formula here. So either one works. If you want to just remember base times height, it's fine. Just keep in mind that with a square, those are going to be the same. So it's really just the same as taking the base and squaring it, okay? And you say, well, why is that really important? Well, let's just imagine, for example, if I'm given this. If they tell me that the area of a certain square is 49 centimeters squared, okay? And they ask me, okay, what is the side length of this? Well, again, for it to be a square, that means that both of my side lengths have to be the same. So what number could I multiply times itself? That will give me 49. And it may be a little bit hard for us to think about it in that context, but let's think about our formula again for a square. And I'm going to use this one this time and kind of show you where its value is. So if A equals b squared, and they're telling me that my area is 49, I could put my 49 right here, and it has to equal b squared. Now let's think for just a second about how do I undo a square? How do I get rid of this? Because I need to know what b is, but right now it's being squared. Well, again, the way that we undo or the inverse of squaring something is to take the square root of it. Okay. So if I take the square root on one side, I have to take the square root on this side as well. And now we understand pretty quickly that the square root of 49 is in fact 7. 7 times 7 would make 49. So that means the base of that particular square would have to be 7. So you can kind of see how that helps us in this context to be able to do this work here. Okay. So now let's talk about one of the ones that's really can be really confusing, especially on an ACT or a standardized test of some sorts. Again, when we're talking about rectangles, squares, and parallelograms, parallelograms is probably the most confusing one. So let's take a look at this one real quick. Just sketch one out really quick. And again, a parallelogram would have two sets of opposite sides. We cannot necessarily say there's any right angles in here, correct? So let's say, for example, this is 10 centimeters. I know we use centimeters as a unit a lot. And let's say this is 5 centimeters. Now, what one may be tempted to do is think, well, okay, it's sort of like a square. It's sort of like a rectangle. It has two sets of opposite sides. Let's just do the same thing again. Area equals base times height. And so many times we go ahead and do that, and we think, okay, area equals base times height. My base is 10. My height has to be 5, so that means 50 square centimeters. And I'm going to tell you, if that is the answer that you come up with, that unfortunately you are wrong. Okay, and the reason goes right back to something that we said a little bit ago. We said that this perpendicular height right here has to be perpendicular. Okay, this height has to be perpendicular. So if you notice, this height is not perpendicular, so we cannot just take that 5 and use it as our height. Okay, so we've got to have a perpendicular height. Now here's what I want you to think about with this particular figure, this parallelogram. We can actually make this a rectangle. Say what? We can make this a rectangle. Yes, absolutely, we can make this a rectangle. So watch what we're going to do now. What if I made a perpendicular line? That was kind of awful, but what if I made a perpendicular line right here? Okay, and imagine me taking a pair of scissors and cutting this along this line. Well, think about what I could then do. Then I could take this portion right here and I could move it over here to this side. Now, all of a sudden, notice, because these are the same and because I have to have the same angles, that means when I move this over here, basically what's going to happen is I will end up with a rectangle. Okay, I will end up with a rectangle. So ultimately, you know what? This is the correct formula. This will work because ultimately any parallelogram can be made into a rectangle. The difference is you have to have this perpendicular height right here. So let's say, for example, that this perpendicular height is 4 centimeters. Okay, and we're just using hypothetical numbers here on this particular one. So if that perpendicular height is 4 centimeters, then I can use area equals base times height, but again, I've got to make sure it's the perpendicular height. So area would equal 10 times 4, not 5, and that would be 40 centimeters squared. Again, a lot of times on the ACT, they will have all three of these numbers on your figure. And so many people, they've got this in their mind, area equals base times height, and they just take 10 times 5 and they move on. And guess what? That will be an answer choice. You can guarantee that on the ACT, that will be one of the answer choices. And so they want to make sure that you understand that you need to multiply the perpendicular height times the base. Okay, so just keep that right there in mind, that your height has to be perpendicular. Okay, so one of the other things you're going to be asked to do is you're going to, just like with rectangles, just like with squares, they're going to ask you to find the unknown length. So let's draw another one of these, and I'm going to intentionally do this the other direction, just so that you can see that they're not always going to be turned exactly the way you think they should be. So let's say that I've got 12 centimeters here. I've got 6 centimeters here. sorry, centimeters. And they tell me that the area is 60 centimeters squared, okay? And they will also probably have you a little dotted line with a perpendicular marking. So remember, my base in area equals base times height. My base is always the side that is perpendicular to my height, okay? So again, my base cannot be this because it is not perpendicular. There's no right angles over here. Notice that this then has to become my base, because if you notice, I've got this here, which was not a very straight line, but I'm working on it. And you've got this here, that is my perpendicular point, okay? So when we're looking at this, we have an area that they're giving me of 60 centimeters squared. Remember that my formula is area equals base times height. So I know my area. I'm going to go ahead and substitute that in for A right here. I know that my base is 6, but I don't know what my height is. And again, this comes right back to similar problems that we've already did before. If I'm multiplying by 6, now I just need to divide by 6. So the H would equal 10 centimeters, not 10 centimeters squared, because I'm not finding the area. I've been given the area and I'm finding a side, okay? So if it's a side length like this, it's not going to be squared, okay? If it is area, then it is going to be squared, okay? So hopefully this has been helpful to you. Again, we're going to build on this tomorrow or the next day. We're going to be talking about triangles and trapezoids. So remember, area equals base times height, and that height has to be the perpendicular height. If you have any issues or troubles, make sure that you reach out to either me or Miss Wheeler, and we'd be glad to help you out with this. Thanks.